is now joining us to tell us how we are going to do just that.
Thanks, Jerome. The metaverse brings several new challenges. Most of the fast progress in AI of the last decade is deeply grounded in the internet. So it's not surprising that we've seen the most progress for data modalities such as speech, language, and vision. Those are the native modalities for the internet. In AR and VR, though, the experience and the affordances are much bigger. So, for example, movement from hands to faces to the whole body becomes a major vector for giving and receiving information. Now, this opens up some fascinating new opportunities and also requires some major progress in our AI models. Jerome shared the goal of building a unified model, but this isn't quite sufficient. We really need to make progress on building world models. A world model is a construct that AI researchers have talked about for years. The idea is to build a rich representation that can be used not just to make predictions, but also to roll forward the future and compare alternative choices of actions or interventions. Compared to a unified model, which is great to represent information, a world model is able to plan and to reason over that really long term. So as we move to building AI agents that can operate fluidly across true reality, augmented reality, and virtual reality, our world models will need to be trained with a mix of static pre-recorded data, like the supervised models, but also a stream of interactive experiences. We don't know yet all the new methods and algorithms that we will develop in coming years, but we already know a few research directions are poised for big changes. Let me highlight today just a few of them, which we are really excited about: embodiment and robotics, creativity, responsibility. The reason we're looking at robotics is that it's a fantastic case where world models can make a major difference. Our focus here is to achieve what we can call unbounded robotics, robots that break out of the lab or highly constrained settings, such as factories, and are able to operate fluidly in the home, in the office, interacting with humans, space, and objects as naturally as possible. And there are several steps to get there. If we observe how people learn, the experience is very different whether being taught a new skill and all they can do is observe. This is what most of our AI systems on the internet are doing right now, learning in a passive way, like a child sitting in front of a TV or computer. Of course, parents and psychologists have long known that learning is much faster, deeper, more transferable when it's done actively through manipulating the world, trial and error, and repeat. Now, one important step as we build robots that learn from rich interaction is that we need the robot itself physically to improve its ability to perceive the world through touch. To get there, we've been experimenting with new touch sensors. One sensor we created recently in partnership with researchers at CMU is Reskin, shown here in a blue glove. This is still a prototype, but quite exciting what we can do. Reskin has a deformable membrane with embedded magnetic particles. When it deforms in any way, the magnetic signal changes. We can measure these changes and use AI techniques to infer the contact location and amount of applied force. And Reskin actually uses self-supervised learning to auto-calibrate the sensor, making it more usable in all sorts of tasks. Another one of the new sensors we built in partnership with GelSight, an MIT spinoff, is the digit sensor. This sensor's surface consists of a deformable elastomer, and it's able to measure contact forces through changes in images recorded by a camera within the sensor. So compared with currently available commercial tactile sensors, Digits is a lot cheaper to manufacture, and it provides hundreds of thousands more contact points. Think of those contact points as the pixels of touch. This is remarkably fine-grained touching. Consistent with our approach on AI models, we've gone so far as to open source the plans for this one, making it accessible to research teams around the world. Once we start having the right sensors, we need to also build the AI models that will make the robot more intelligent. For example, hold objects robustly. This builds most closely on our work on unified model for the perception aspects, but we really need the world model here to plan how to pick up, manipulate, and place the objects without making a mess of things. As with most of our research work, we've built and released an open source library, in this case, the PyTouch library, that includes several functionalities such as detecting touch, slip, estimating the robot pose, and the object itself. This can all be included as part of a broader system with navigation and other robotics capabilities. One of the interesting challenges in all this work is to create some models that can operate both in the real world through physical robots, physical objects, but also in virtual worlds, allowing our avatars to pick up and manipulate objects in a realistic way and to ensure consistency from one to the other. To bridge the gap from reality to VR, our Habitat project explores developing a full photorealistic environment synthetically generated from thousands of scans of indoor environments with a physics-based engine for interactions. It's pretty sweet. Here we can train, test new algorithms for robot navigation and manipulation with realistic sensing and interaction with space and objects. It's a fantastic playground and a close cousin to the world builder you saw earlier in Mark's talk. While simulation's a great way to accelerate our research towards immersive environments, there's still a lot of work to do. In fact, there's still a big gap between simulation and the real world, and much work to do to build some truly reliable world models. In particular, doing physics simulation in real time at all levels of resolution, from fine contact with the objects to the full body motion, is really very hard. But is it really necessary for our world models to be that precise all the time? That's an interesting question. In fact, the video gaming industry has often challenged this in a really interesting way. Many games totally sidestep the idea of realistic simulation by simply making interactions wildly different from what we know in the real world. One of the things I'm most excited to see in coming years is that same explosion of creativity, but fueled by the new capabilities in AI models. In this vein, let me share with you one short project, a particularly fun one recently out of our Meta AI research labs. Rather than trying to sense and recreate the real world, this one leans into the inner child we all have inside of us. It's a new approach to storytelling. And for people such as myself, whose artistic talent is best identified with the primitive period, this is just perfect. It starts from a simple drawing of a character and brings it to life in a short animated video sequence. Let's have a look. We start with a simple drawing of a character. It then uses our state-of-the-art object detection model, MaskR CNN, as implemented in the open source Detectron library, to detect the figure from the background. We then use AlphaPose, a model trained for human pose detection, to identify key joints on the character. Once we have the mask, the joint predictions, we can move the character into various poses. We can select different motions, jumping, dancing, waving, to apply to the joints we detected. The results is really quite charming, and it's a great one to try with kids. This is just the beginning. You can expect to see a lot more as we explore new ways that AI models can enhance human creativity. But as we build all of this new research and technology, we have an opportunity to get this right or to get this wrong. With the metaverse, we can learn in a much more dynamic, interactive, creative way Yet I'm keenly aware that the people who drive the research and who collect the data we feed into the AI models have a large influence on what products and experience we enable. So as we embark on a new journey of building AI for an embodied, interacting metaverse, we really need to raise the bar on how we do it and what values we are going to promote in our design and our technology. So Jerome, before